Welcome back to G Tutorials. Today, we're exploring graphs, focusing on parabolas. Before we get to curves, let's clarify the basics. A relation is just a set of pairs, like students and their test scores. But a function is stricter. Each input gives exactly one output. Think of a vending machine that always gives you one snack per button. For example, y equals x plus 2 is a function. Pick any x and you get one y. This predictability is why functions are so useful in graphing. Each point on a graph is an x-y pair that fits the function's rule. Not all relations are functions. For instance, a circle's graph fails the one input, one output rule. One x can give two y's. So a circle is a relation, but not a function. Understanding this difference is key to mastering graphs. Functions let us predict and describe patterns visually and mathematically. They're the foundation for everything we'll do with parabolas. Ready? Let's meet the quadratic function. Meet the quadratic function, the star of our show. Its graph, y equals sine x2, forms a symmetric U-shape called a parabola. The vertex or lowest point is at 0, 0, and the axis of symmetry runs through the y-axis. We often use vertex form y equals sine a x h2 plus k. Here, hk is the vertex. The minus sign means the vertex's x-coordinate is the opposite of what's inside the bracket. For example, y equals sine x3, 2 plus 4 has its vertex at 3, 4. The a value controls the parabola's direction and width. Positive a opens up, negative a opens down. If vertical bar, a vertical bar 1, the parabola is narrower. If 0, vertical bar, a vertical bar 1, it's wider. Vertex form lets us see the parabola's shape and position instantly. By reading the equation, we can visualize the graph before plotting. This is the power of understanding quadratic functions. Let's see how changing h and k moves the parabola. Now let's make our parabola move. This is called translation. Changing k and y equals sine a x h2 plus k shifts the parabola up or down. For example, y equals sine x2 plus 2 moves the parent parabola up by 2 units. Changing h shifts it left or right. Y equals sine x3. 2 moves the vertex to 3, 0, 3 units right. The sign inside the bracket is opposite. xh means right. X plus h means left. Let's compare two equations. Y equals sine x plus 1, 2, 5 and y equals sine x plus 1, 2 plus 2. The vertex moves from 1, 5 to 1, 2, a vertical shift of 7 units up. The shape stays the same since a hasn't changed. Translation is like sliding the parabola to a new spot without stretching or flipping it. By adjusting h and k, we control the parabola's position on the grid. This makes it easy to match equations to graphs and vice versa. Mastering translations helps you quickly sketch and interpret parabolas. Next, let's see how this applies to real-world problems. Parabolas appear everywhere like the path of a thrown ball. Suppose the height ht equals sine 5 t2, 2 plus 25 models a ball's flight. The negative a means the parabola opens down, the ball rises, peaks, then falls. The vertex, 2, 25, tells us the ball reaches its highest point, 25 meters, at 2 seconds. To find the starting height, plug t equals sine 0h, 0, equals sine 5, 2, 2 plus 25 equals sine 20 plus 25 equals 5 meters. So the ball starts at 5 meters, peaks at 25, then descends. The graph shows the entire journey, launch, peak, and fall. We can use the equation to find when the ball lands or reaches any height. Quadratic functions let us model and predict real events with precision. That's the power of connecting equations to real-world stories. Translating functions isn't just for parabolas, it's a universal math tool. The same shifting rules apply to sine, cosine, exponential, and logarithmic graphs. H and k always control horizontal and vertical movement. Mastering translations with quadratics prepares you for all kinds of functions. Engineers, architects, and analysts use these ideas to solve real problems. Moving a graph means adapting a model to fit any situation. When you shift a parabola, you're learning a language that applies everywhere in math. Connecting equations to graphs builds powerful intuition. Keep exploring. These skills will serve you far beyond the classroom. Thanks for joining this journey into the world of parabolas. Hope you find this video useful. Please don't forget to share with your peers. See you in the next school year. Enjoy your summer!